This is my Physics 1 Lab 4 presentation on oscillations. So the purpose of this lab is to investigate the energy principle. Specifically, we want to determine whether an object in a spring mass system orbiting in a conical pendulum-like orbit exhibits qualities of the energy principle. So fundamental principles that are used in this lab are Newton's second law, or the momentum principle, that states that the net force is equal to the change in momentum over the change in time, and also that the net force is equal to the force of gravity plus the spring force. And below you can see that that is extended. Also, the energy principle, which states that the change in energy of the system is equal to the work of the surroundings plus heat. And also some update formulas, which includes the position update formula, the velocity update formula, kinetic energy, the potential gravitational energy, and the potential spring energy. So introducing the experiment, the system would be the spring, the ball, and the earth, and the surroundings would be nothing. So we're essentially isolating the system, which means that the change in energy of the system would equal zero, and therefore change in kinetic energy plus the change in spring potential energy plus the change in gravitational potential energy would also equal zero. The mass of the object is at 0.402 grams, and the position and velocity initial values are stated here. So the result of this experiment is that the total energy is zero throughout, which successfully demonstrates the energy principle. So taking a look at our code here, the ball's mass and the initial position and velocity values are stated here. Additionally, I was able to calculate the spring constant using the equation T equals 2 pi squared times the square root of m over k, with T equal to the average time interval between oscillations. We found the relaxed length of the string by using the equation net force is equal to the spring force plus the gravitational force. So as you can see here, I took the average of 3 time trials to find an average of approximately 1.5 seconds. And using that value here, we were able to find the spring stiffness of around 7.19 and also the relaxed length of 0.15 by plugging in the values. So here we are also just plugging in the values from the equation stated earlier in the presentation. And we did the same for here as well, while t is less than 9.5, which is the length of the video. So after the code is run, you can see that the computer simulates the pendulum and that delta E remains constant, with the model being approximately similar to the experiment. So as you can see, the model and experiment graphs were not completely aligned, and this leads us to our possible errors. So one of them can be the wrong center of mass placement, where human error in clicking not completely directly in the center of mass of the object can affect this, and as well as work done on the surroundings, which means that the video in reality is not in an isolated system, which means that there will be work acting upon the system, which could be potential reasons for why the two graphs are not completely aligned. So what does this mean? Is the energy principle satisfied? And the answer is yes, because as you can see earlier, the orange line is approximately constant, which means that the change in energy remains constant regardless of the different kinds of energy in the system. So now we are comparing oscillation periods, and we did this earlier in our code, but just to reiterate, the average time is calculated between 3 time trials, with the spring stiffness being a function of t. In the x direction, the average time is approximately 1.3 seconds, and as you can see here, it was adding the average of these 3 time trials. And the same in the y direction with approximately 1.5 seconds, doing the same thing between the peaks. And as you can see here, the oscillation periods also affect the spring stiffness, with the spring stiffness in the x direction being a little higher than the spring stiffness in the y direction. And that is all. Thank you for listening to my presentation.